Okay, question 2b, part 4, probably my favourite question on the paper. Complete the following flowchart for the synthesis of compounds D and E from phenylethanone. So you've got a monster synthesis question, lots and lots of marks, and all this is if you can remember those synthesis routes. If you remember those, remember the conversions, and these are easy marks. Okay, but obviously it depends on your ability to memorize all those conversions that you've been given. So let's start at the top. With phenylethanone reacting this whole molecule with NABH4. So look at the reagent, NABH4. What does that twig in your memory? This is a reducing agent used when we react aldehydes and ketones. And it reduces an aldehyde or a ketone back to a primary alcohol or secondary alcohol, respectively. So looking at what we've got here, we've effectively got a ketone on the phenylethanone. So the reaction of this molecule with NABH4 is going to reduce the ketone here back to a secondary alcohol. It will not do anything else to the benzene ring, and it's not going to do anything to the CH3. All we're going to get is the CH3 still in place, an alcohol in place of the double bond O, and the other hydrogen there. Okay? And that's the bit that students commonly forget. Remember, carbon has got to make 4 bonds. All right? It isn't on this molecule, but in part of the reduction, it gets itself placed on. Okay? If I carry on down this side then, come down this corner here, what's happening here? I'm taking my alcohol, and that's becoming an alkene. So this is a year 1 reaction. Alcohol to alkene is elimination, the removal of a water molecule, okay, between the 2 carbons, between the CH3 here and the COH. So we're going to take away a hydrogen, and we're going to add a double bond in its place. Now, in order to do that, all I need is an acid. So either simply writing an acid, or you could write H+, or you could write a specific acid. You could say sulfuric acid, or you could say phosphoric acid. Didn't even have to mention concentrated or dilute. That's all they wanted there, was just indication of an acid. Let's go back to the other side. Phenylethanone then reacting to produce something, and then this something reacting with something to get to a brominated molecule, and we've got a nitrile on there as well. So this is quite a tricky one to do. We know what we're reacting our phenylethanone with here. So the nitrile is in there, so we must be dealing with this bit first. Therefore, this section has got to be putting the bromine on. So let's have a look how we can do this. Reacting a ketone with a nitrile is going to produce a hydroxynitrile. So again, I'm not going to change my benzene ring in any way. I'm still going to have my CH3 on there. Hydroxynitrile then will be OH and then CN. So it's going to look something like that. All right. Remember, reacting a ketone or an aldehyde with the CN minus ion or sodium cyanide and hydrogen ions, whichever way you want to try and remember it, produces a hydroxynitrile. Now, if you look now, logically, what I'm trying to do is replace my OH with a Br. Okay? Now, this is a substitution reaction. Again, it's year 1. How do I change an alcohol to a haloalkane? Well, I need sodium bromide. I need sulfuric acid. Okay? So far on this synthesis route, we've got year 1 reaction here, and a year 1 reaction there as well. So you can't just forget about those year 1 synthesis routes. Coming down again, so what I've got here, I've got my brominated molecule, I've now got my nitrile on there. I'm going to change that via an intermediate step into an amino acid. So I've got to replace my bromine with an amino group. My nitrile's got to become a carboxylic acid. Okay, so there are actually a couple of ways you could do this. The best way to do this, and the most correct way to do this, would be to change your nitrile to a carboxylic acid first, and then change your bromine into the amino group. But you could do it either way. You could do the amino group first, and then the carboxyl afterwards, and both would be perfectly suitable. Okay, so how do I change a nitrile into a carboxylic acid? Well, that's simply reaction with an acid. So H plus could be used in there. We could use sulfuric acid. We could use hydrochloric acid. All right, now ideally you should have this as aqueous acid, but in this case they've not requested it. They've just asked, they have advised on the mark scheme that it's not necessary. That's then going to produce beg your pardon, it's going to put a CH3 there. You're going to have your bromine there, and you're going to have your carboxyl group there. Okay, now going this way. Now, bromine being replaced with an amino group, that is going to be ammonia and ethanol. And there's your completed synthesis. So like I said, these last two steps, you could do this one first, put the ammonia and ethanol in, keep the nitrile and put the amino group on, and then do this section to change the nitrile into a carboxylic acid going that way. It makes no difference which order you did that one in. So, nice 7 mark synthesis question.